Hello, hopefully you've already watched Miss Saunders' video on partial fractions. I thought it might be worth working through a second example. This one, if anything, is a little bit easier than the one that Miss Saunders did. I've only got two terms in my denominator here, and that's going to make it a little bit easier than the three terms that Miss Saunders had in her example. Okay. What are we going to do first? Well, I'm going to write this as an identity, so it's equivalent to the sum of two fractions. In the first fraction, I'm going to pick up the first term in the denominator, so I'm going to pick up my 2x, and then my x minus 4, my second term, is going to be the denominator of my second fraction, and I'm going to add the two together. I don't know what's on top yet. I'm going to call them a and b. Do check the question really carefully. Sometimes the question will give you the split of the two fractions, and it will tell you which variables to use. So if it's given you letters, you must use the letters that are in the question. In this case, we haven't been given anything, and I've chosen to use a and b. That's absolutely fine. Use your own choice. But if you have been given the letters in the question, you must use those, otherwise it gets really confusing and you'll lose some marks. Right, so what do we got? We've got this horrible fraction on the left, and it's equivalent to these two fractions over here, quite a lot simpler. What I want to do is I want to convert this into one equivalent fraction. So it's going to be back into this form, and then I can compare the left hand side and the right hand side of this identity. So what have we got? We have got a common denominator is going to be 2x into x take away 4. So for the first fraction, what do I multiply that by to get this expression? Well, I've got the 2x already, so I need to multiply top and bottom by x minus 4. So we get a x minus 4. And then the second term, we've got b over x minus 4, so I've already got the x minus 4 term. I need to multiply top and bottom by 2x. So plus b times 2x. Now we've got the same denominator in both cases, so this expression on the numerator here has got to be the same as the numerator over here. So I'm going to write that down. So minus 7x minus 12 is going to be directly equivalent to a into x minus 4 plus, just going to rewrite that as 2bx. That approach we're going to use for both our methods, our substitution and our equating coefficients. I'm going to start off with the substitution method. This is my personal favourite, it's my go-to method. I only ever tend to use the equating coefficients if the question tells me to. So again, if they give me a strong instruction, I must follow the equating coefficient approach, then that's the method I need to use. Other than that, I'm going to use substitution. Right, what are we going to do? So, well, what have we got so far? We've got an identity, we've got some x's in, our variables, and we've got these two coefficients a and b which are unknown. So we're trying to solve for a and b. And we can substitute in values of x that are going to give us expressions in terms of a and b, which we can solve to calculate our values of a and b. Now, I could pick any numbers to substitute in for x, but I'm going to pick the ones that are going to make either this term or this term disappear. So the easiest one to start off with is x equals 0, because if x is 0, then 2bx is 0, and then I'm just left with my term over here with a in. So I'm going to substitute the value x equals 0. So on the left, minus 7x, well if x is 0, that's going to disappear. It's going to leave me with negative 12. So negative 12 is equal to my a value, x is 0, and then taking away 4, so I'm going to multiply that by negative 4, and then I've got two lots of bx. Well, x is 0, that term's going to disappear. So I've got negative 12 is equal to negative 4a, so divide both sides by negative 4, a value must equal 3. So divide by negative 4, I've got an a value is equal to 3. Now I want to work out what b is. So this time I'm going to substitute the value that's going to make the other bracket disappear, so my x minus 4. So if I substitute in x equals 4, that bracket's going to disappear, and I'm going to be able to work out what my value of b is. So if x is equal to 4, what do we get? On the left hand side, I've got negative 7 times 4, take away 12, and that's going to be equivalent to a times 4, take away 4, that's going to disappear, that's why I substituted x equals 4. And then I'm going to get plus 2b multiplied by x, which is my value 4. So I've got negative 28 subtract 12 is equal to 8b. So I've got negative 40 is equal to 8b, and b is equal to negative 5. So I've got my two values. I've got my value of a and my value of b. If I'm lucky in the mark scheme, I'll pick up all the marks in the question. However, sometimes the question insists that I restate my identity. So what have we got? We've got minus 7x minus 12 over 2x into x minus 4, and it's identically equal to my value of a, which was 3, over 2x, just disappearing off the top of my page, so 2x plus my b over x minus 4. Well, b was negative 5, so I'm going to subtract 5 over my term of x minus 4. That way I'm guaranteed to pick up all the marks in the question. So I might be lucky if I've got my a and my b values of getting the marks, all of them, but to pick up that final accuracy mark, sometimes I need to restate. It's always safest to do so. Okay, so that was my substitution method. Let's have a look at my equating coefficients. So equate coefficients, what have we got? I'm going to go back to this same equation, the same identity that I've got at the top. So I've got minus 7x, let's go down here, minus 7x minus 12 is equivalent to, what I'm going to do is I'm going to collect my x terms together. So I've got, let's write it here just so it's underneath itself. So we've got a, x minus 4 plus 2bx. So minus 7x minus 12 is equivalent to, if I collect my x terms together, I've got a plus 2 lots of b. So I've got ax here, 2b lots of x, so if I factorise that, I've got a plus 2bx. And then my constant terms, I've got a times negative 4, so negative 4a, and I don't get anything on the right hand side. So I've got, on the left, I've got 7 lots of x, equivalent to this a plus 2b lots of x. Then I've got a number, negative 12, and that must be equivalent to this negative 4a. So if I have a look at my coefficient of x squared, the number that I've got in front of my x, well, on the left I've got negative 7. That's got to be equivalent to this bit here, this a plus 2b. So it must be equal to a plus 2b. So negative 7 is equal to a plus 2b. I can't solve that yet. I've got an equation, I've got two variables, not got enough information to solve. So let's have a look at my number. So in this case, so those are my 7x's, my number term, my negative 12, that's got to be equal to, those are my x's, this is my number at the end, negative 4a. So negative 12 equals negative 4a. Well, I can solve that, I can divide both sides by negative 4, I'm dividing by negative 4, and that's going to give me a equals 3. Same value that I've got over here, so I'm feeling fairly confident. Right, what have we got left? I still want to work out what b is. I've got this equation up here. I know what a is now, so I can use that to solve for b. I've got negative 7 is equal to a, which is my value 3. That's 2 lots of b. Subtract 3 from both sides. Negative 10 equals 2b. b equals negative 5. Again, same value that I've got over here, so I'm feeling fairly cocky. I haven't made a mistake. Again, if I'd gone through that equating coefficient approach, I would have restated my identity, so my original fraction, and I would have stated it as the equivalent partial fractions over here to make sure that I'm picking up all the marks. So it's your choice as to which of those two methods you use. The equating coefficient one, I end up with two equations with two unknowns if I've got two partial fractions like I've got here. If I get three partial fractions, I end up with three equations with three unknowns, and I've got quite a lot of extra work to go through to work out what my values of a, b, and that third value c are going to be. However, if you use the substitution approach, and you substitute in, you pick your values correctly, two of the three terms will cancel, and you're left with an ability to work out what that third variable is. So it tends to be quite a lot easier when you've got 3 or more variables to use this substitution approach. So that tends to be my preferred route. You do need to know both, and if you prefer this approach, brilliant, just stick with it. But make sure you're comfortable with both. Try a couple of the questions with the substitution method, try a couple with the equate coefficient method, and then pick a method and stick with it. Excellent.